Using dot-to-dot technology and matrices, we can create points for the turtle to go to produce incrementally different 2D perspectives of the 3D object. We create the list points to store the points for the turtle to go to. The idea of this is to draw the four edges connecting the front face to the back face. This mini block of code draws one of the edges and goes back to the position before starting to draw the edge. The transition between drawing the edges draws the front face in the meantime. This is necessary as the turtle can only leave a trail along the edges of the cube or there will be unwanted diagonals. We thus employ this systematic method to draw the cube. After completing a list of points, we need to project the 3D points on the 2D plane. The 2D plane will have one of the 3D axes missing, so we use matrix multiplication to create 2D projected points. These matrices are 3 by 3 unit matrices, but with one of the rows removed. When the 3D point matrices are multiplied with a 2D projection matrix, we have a 2D projected points. Now I will paste code that draws a 2D projection of the cube. The purpose of the point dot reshape 3, 1 is to rearrange the point into a matrix with 3 rows and 1 column so that it can be multiplied with the projection matrix of 2 rows and 3 columns to produce an output matrix of 2 rows and 1 column, which contains the 2D projection coordinates of each point, which can now be plotted onto the turtle canvas. The reshaping of the point matrix was necessary so that the number of the rows in the point matrix is the same as the number of columns in the projection matrix, which is a requirement for matrix multiplication to work. Now I will run the code. And the cube is now projected. We will define the rotation matrices. Now that we have written the rotation matrices, we will actually use them. And you see nothing. And you still see nothing. And now we have a cube that spins in the y-axis. But we're not done because this is all we've achieved. We can achieve more than that, can't we? So we've achieved something more. This is good. And still have yet to explain about why I put point or reshape here, because when you multiply a matrix rotation y that has 3 rows and 3 columns by a matrix point dot reshape points, which has been reshaped into a matrix with 3 rows and 1 column, you get a matrix that still has 3 rows and 1 column. So that was a point of that. And now the rotation matrix has been multiplied into the point. We have a cube that spins, and we're not done yet because we still have a rotation matrix to do. And we have a problem. Didn't define it properly. And we have this kind of spin. And we still, and then instead of removing the x-axis, we could also do the z-axis. Which produces this kind of results. And also instead of doing that in this order, rotation in this order, we could do something else which produces a different kind of rotation altogether. And we could also do something as well as it we could remove one kind of rotation altogether. Let's remove the zero, and we have this kind of rotation. And then that's how you code a sphere cube. That's the end of this video.